Alright, so we're going to be learning about the following that you can see on the screen. It's going to be reviewing about the chapter about special right triangles, 45, 45, 90, 30, 60, 90, as well as angles of elevation and depression, and also angle side measures. The first problem we're going to be doing is going to be to do with this triangle right here. And we're going to be trying to find what n is and then what m is. So there really isn't an equation to this one. All we need to know is that with 45, 45, 90 triangles that the lengths of the legs are equal. So if this is 9, then n is going to equal 9 as well. And for the hypotenuse, all we have to do is take the length of the legs and tack on 2 squared. So it's going to be 9 2 squared, like that, to start. And so what we're going to be able to, or what we're going to have to find is A, and B. This kind of looks like a 6. There we go, A and B. Just to find what they equal. And so what we'll be able to find is that, so since B is the short leg, I could write short leg and long leg. Since B is the short leg, it is going to be 3 and a half, because half of 7 is 3.5, because like we discussed earlier, the hypotenuse is going to be, or the short leg is going to be half of the hypotenuse. And the long leg is going to be 3 and a half square root of 3, because, like we said earlier, the short leg, or the long leg, is going to be the same thing, but with square root of 3 tacked on at the end. So this is how you would find the lengths of the legs given the hypotenuse. For our second angle of elevation depression problem, we have a triangle where we are given the angle of elevation and the length of the object in the distance. It could be like a building or anything. And we have to find the hypotenuse. So how we would do that is we have to determine, using SOHCAHTOA, which, if this is sin, cosine, or tangent. And so we have the opposite as well as, and we're trying to find the hypotenuse. So what we have to do is we have to use sin 3 degrees, because that is our angle of elevation, equal to 1707, the length of the building, or any object that the angle of elevation is referring to, over x. So when we're given a situation like this, where the x is on the bottom, unlike the last problem where the x was on the top, we have to multiply by x. And what we are left with after that is we are left with x times sin 3 degrees equal to 1707. And now what we have to do is we have to divide by sin 3. And when we do this, we cross this out. It destroys itself. And we are left with x times nothing, so it's equal to 32.616. And that is the angle of the length of the hypotenuse. To use SOHCAHTOA. And so we are given, so if we look at this, we can see that we are looking for the opposite, and we have the adjacent. So that sounds a lot like the tangent. So we're going to use tan 5 degrees equal to O over A. And so now we have to plug in our numbers. So tan 5 degrees is equal to the opposite of x over the adjacent of 150. Now we have to take x equal to 150 in parentheses of tan 5 degrees. And then when you plug that into a calculator, or just solve it by yourself if you're that intelligent, you get x equal to 13.12. That is the length of there. And that is how you find a triangle when you are given the side measure with an x numerator, seen here. Because when the x is on the bottom, things get a little bit more complicated.